Hello everyone. Our problem is to show that integration 0 to 1 log x over root under 1 minus x square dx equals to pi over 2 times log 1 over 2. So before solving this problem, we need to know two properties of integration, and they are: the property number 1 is integration 0 to a f of x dx equals to integration 0 to a f of a minus x dx, and the other property is integration 0 to n times a f of x dx equals to n times integration 0 to a f of x dx. I'll make this as property number a and this as property number b. So now move on to the question solution. Our question is integration I equals to 0 to 1 log x over root under 1 minus x square dx. So whenever in denominator you see a form like this, something like root under a square minus x square, you can substitute x equals to a cos theta or a sin theta, whichever you like to use. So I'll go with a sin theta. In our case the a is 1, so putting x equals to sin theta. Now differentiate both sides with respect to theta, we get dx equals to sin, the derivative of sin theta is cos theta, and d theta. Now since we changed x into in terms of theta, we have to change the limit of x as well. So when x equals to 0, when x equals 0, plug this value into this equation, we get 0 equals to sin theta, so we get theta equals to 0. And when value of x is 1, when x equals to 1 equals to sin theta, theta equals to sin inverse of 1, and that is theta equals to pi over 2. So we have changed our integration to I equals to integration 0 to pi by 2, and log in place of x we can write now sin theta over 1 minus sin square theta, and in place of dx we can write cos theta d theta, cos theta d theta, 0 to pi over 2 log sin theta over in denominator 1 minus sin square theta is cos square theta, and that square and this square would cancel out, so we'll get cos theta. Now this cos theta and this cos theta will also cancel, and we are left with 0 to pi by 2 log sin theta d theta. Now I will make this as equation number 1. Now we have to use this property number a. Using property number a, we get I equals to integration 0 to pi by 2 log sine. Now see that in place of x we have written a minus x, and this a comes from this upper limit. So in place of theta we will be writing pi by 2 minus theta. So pi by 2 minus theta and d theta, 0 to pi by 2 log, and sine pi by 2 minus theta is cos theta d theta. And I'll make this as equation number 2. Now what we can do is add this equation 1 and equation 2. Adding 1 and 2. So I plus I will be 2i, integration 0 to pi by 2 log sine theta d theta plus integration 0 to pi by 2 log cos theta d theta. And since we have same integration, we can write it as a single one, 0 to pi by 2, and log a plus log b. Log a plus log b is log a times b. What I mean to say is that log a plus log b equals to log ab. So we can write log sine theta times cos theta, sine theta times cos theta, and then d theta. Now 0 to pi over 2 log. Inside this bracket, now multiply numerator and the denominator by 2. We get 2 sine theta cos theta over 2 d theta. Now let's go here. We have 2i equals to 0 to pi by 2 log. Now 2 sine theta cos theta is sine 2 theta. So we can write sine 2 theta here, and in denominator we just have 2. Now we have solved our question up to this point. Now again what we have to do is another property of logarithm, that is log a by b is log a by b equals to log a minus log b. So 2i equals to 0 to pi by 2 log a minus 0 to pi by 2 log 2 and d theta. Now we have to do another substitution. Put 2 theta, or you can say put t equals to 2 theta. In place of this 2 theta, we will replace this with t. Differentiate both sides with respect to theta. dt by d theta equals to 2. Then we get d theta, we get d theta equals to dt over 2. Now since we changed theta in terms of t, so we also have to change the limit of theta into the limit of t. So when theta equals to 0, use this value in this equation. When theta equals to 0, t is also 0. And when theta equals to this pi over 2, t equals to 2 into pi over 2 means just pi. So we have changed our limit. The next step we have 2i equals to 1 over 2 integration 0 to pi log sine t dt minus log 2 integration 0 to pi by 2 d theta. Notice that we have not changed limit for this integration. We only change the limit for this first expression. Now 1/2 0 to pi log sin t dt minus log 2. Now evaluate this integration. Integration 1 d theta means theta 0 to pi by 2. 1/2 integration 0 to pi log sin t dt minus we will get pi by 2 times log 2 from this part. And now for this part we have to use that rule number b. So 1 by 2 0, we can write pi as 2 times pi by 2, which means the same. So we have got this. Now 0 integration 0 to n times a f of x dx means n times integration 0 to a f of x dx. Now these two and these two will cancel. We have to so we have t2i equals to integration 0 to pi by 2 log sin theta d theta minus pi by 2 log 2. Don't worry about this part. Here we have sin t dt, but I have written sin theta d theta. I haven't done anything, just I replace t with theta. So if you go back to the previous slide, here you can see that integration 0 to pi by 2 log sin theta d theta is I. So here we can replace integration 0 to pi by 2 log sin theta d theta with I. So we get d2i equals to I minus pi by 2 log 2. 2i, this I when it moves to here we get minus I equals to minus pi by 2 log 2. 2i minus I, we get I equals to minus pi by 2 log 2. Let's move here. We have I equals to pi by 2 log. Now minus means we have minus 1 here, so minus 1 will go as a power of 2, so we get 2 to the power minus 1 pi by 2 times log. So 2 to the power minus 1 equals to 1/2, so we can write 1/2. Therefore I equals to pi by 2 log 1/2. Hence we prove the given problem.